Trigonometry, Chapter 2, Acute Angles and Right Triangles, Section 2, Trigonometric Functions of Non-Acute Angles, Video 1, Reference Angles. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous section, we learned about trigonometric functions of acute angles by embedding them in inside right triangles. In this section, we extend the discussion to non-acute angles. In this video, we explore a concept called reference angles, which will allow us to study non-acute angles by associating them with acute angles. We start by considering a non-quadrantal angle, theta, in standard position. Recall that a quadrantal angle is an angle whose terminal side lies on an axis, and hence it's a multiple of 90 degrees. So in this case, we're discussing angles whose terminal sides lie within a quadrant as opposed to on an axis. For any non-quadrantal angle theta in standard position, the reference angle, denoted theta prime with the apostrophe, is the least positive angle between the terminal side of theta and the x-axis. Reference angles do not have signed directions. All reference angles are positive regardless of the direction of rotation. As such, a reference angle theta prime is always between 0 degrees and 90 degrees, and hence is always acute. How you calculate theta prime depends on which quadrant the terminal side of theta is in. For example, let's calculate the reference angle for theta equals 150 degrees, whose picture we see here. The reference angle is the least positive angle, regardless of direction, between the terminal side and the x-axis. In this case, the terminal side is in quadrant 2. And here's the x-axis. So the smallest angle is going to be in this little corner here. This is the reference angle theta prime, and it's measured between the terminal side and the negative x-axis. So how big is that? Well, since the reference angle, the one in red, combined with the 150 degrees in green, makes a half revolution, we have theta prime plus 150 degrees equals 180 degrees. Solving that, we get theta prime equals 30 degrees. The reference angle for 150 degrees is 30 degrees. In general, for any theta between 90 degrees and 180 degrees, the reference angle is theta prime equals 180 degrees minus theta. Now, this may seem like a quadrant 2 rule, and although it seems like that, there are other angles in quadrant 2 where this does not correctly calculate the reference angle. You'll see why later. How about theta equals 210 degrees? Well, to calculate that reference angle, we have to find the smallest positive angle between the terminal side, which is in quadrant 3, and the x-axis, in this case, the negative x-axis. That will be in this little corner here in quadrant 3. We'll call it theta prime and mark it red. And how do we find it? Well, not to give it away, but if you look at it closely, it goes beyond the green angle by a certain amount. Since the top semicircle, 180 degrees, followed by theta prime in red, gives all of theta 210 degrees, we have 180 degrees plus theta prime equals 210 degrees. Subtract 180 from both sides to get 30-degree reference angle. The reference angle for 210 degrees is 30 degrees. And in general, for any angle theta between 180 and 270, the reference angle is theta minus 180. Again, this seems like a quadrant 3 rule, but there are other angles in quadrant 3 where this rule doesn't work. It's the range between 180 and 270 where this rule applies. What if we're in quadrant 4 with something like 300? Where do you think the reference angle is going to be? Well, it's going to be between the terminal side in quadrant 4 and the positive x-axis. So it'll complete this revolution right there. So how do we find its measure? Well, I just gave you a hint. The angle we have 300 degrees, followed by the theta prime would give us 360 degrees. So 300 degrees plus theta prime equals 360 degrees. Subtract 300 and we get that our reference angle is 60 degrees. And in general, for any theta between 270 and 360, the reference angle is 360 degrees minus theta. And again, this seems like a quadrant 4 rule, but there are other angles in quadrant 4 where this rule does not correctly calculate the reference angle. Before I comment about why these three rules aren't really quadrant rules, we should clarify that what the reference angle is for an angle that's already acute, like 50 degrees. Well, because the least positive angle measure from the terminal side is already measured 50 degrees between the terminal side and the x-axis, 50 degrees is its own reference angle. So in general, for any angle between 0 and 90, it is its own reference angle. So why aren't we calling these quadrant rules instead of classifying them by angle size? Because there are other angles outside of 0 to 360 where these rules would fail to work. So although the definition of reference angle does not change outside this interval, we will have to make some adjustments, and we'll explore this in a later section. Now you try. Pause the video and try the following. Find the reference angle theta prime for each given angle theta. All right, here's your fair warning if you haven't paused the video. Solutions in 3, 2, and 1.